Hello students, good morning to all. Our today's topic is hyperbola continuation. Today is the last session for hyperbola. Okay, yeah. So already in the last class we have discussed about position of a point with respect to hyperbola. Next, what is rectangular hyperbola, and next we have learned about what is tangent line to the hyperbola. Okay, in the last class and the respective problems also we have done. And in today's class, okay, in today's class, what we are going to learn, we are going to learn about common tangents, right? And next, after common tangents, directed circle, then after directed circle, normals, okay. After normal, diameter of the hyperbola. So we are going to learn these topics in our session. And next, see what you are seeing on the screen. That is a Spark Academy app. Try to install the app. Test. Okay. Then let us say directed circle. Directed circle. So what is the equation of the hyperbola? Once again, we can change the color. Okay, so we know that the equation of the hyperbola is x square divided by a square minus y square divided by b square equal to 1. This is the equation of the hyperbola. Now, uh, here there is a point P. From this point P, we are drawing the tangents. Okay, this is the first tangent to the hyperbola, and this is second tangent to the hyperbola. What do we mean by directed circle? Directed circle is the locus of the point of intersection, locus of point of intersection, locus of point of intersection of tangents, locus of point of intersection of tangents at right angles, tangents at a right angle. So here it could be 90 degrees. Then the locus of this point, let it be h comma k. So locus of the point P of h comma k is called directed circle, right? And as it is hyperbola, we know the equation of the tangent. What is the equation of the tangent? Equation of tangent is y is equals to mx plus under root of plus or minus also written it plus a square m square minus b square. This is the equation of the directed circle. Now, sorry, this is the equation of the tangent. Now the tangent is at point P. So substitute the point P in this, then you can get k is equals to mh plus under root of plus or minus under root of a square em square minus b square. So bring mh that side, k minus mh is equal to plus or minus under root of a square m square minus b square. Then do squaring on both the sides. If you do squaring on both the sides, we can get k minus mh whole square, which is equals to a square m square minus b square. Let us simplify this. K square plus m square h square minus 2m hk, which is equals to a square m square minus b square. Okay, then here we can write all the terms one side, and here we have one m squared term, here also we have m squared term, then h square minus a square of m square. Okay, now h square minus a square of m square. Next, this is m term minus 2hkm. Next, constant terms, the constant terms plus k square, and n minus v square this side, it will become plus v square, which is equals to 0. So here it is the quadratic equation. It is the quadratic equation in terms of m. So it has two roots. Let us take m1 and m2. Let us take m1 and m2. So here m1 is the slope of the first tangent and m2 is the slope of the second tangent. From the figure we know that the two tangents are perpendicular to each other, then the product of their slopes is minus 1. m1 times m2 is minus 1. Then here what is m1 times m2? That is a C by A formula. So it is k square plus b square divided by h square minus a square, which is equals to minus 1. Then we can get k square plus b square is equals to minus h square plus a square. Minus h square plus e square. Bring all the terms, bring h to the left side. We can get a h square plus k square, which is equals to a square minus b square. So here h comma k is the locus of the point. Then we can write this as x square plus y square is equals to a square minus b square. X square plus y square is equals to a square minus b square. This is called director circle. Understood? Next, after director circle, normals. Normals to the hyperbola. So let us draw the hyperbola here. Right? And here let us take, suppose this is point P. At point P, this is the normal. At point P, it is the normal. Right? Then here we have to calculate what is the equation of the normal. So here we can calculate the equation of the normal in point form, parametric form, and in slope form. First, let us take here the point is some x1 comma y1. Let us take the point is x1 comma y1. And what is the equation of the hyperbola? X square divided by a square minus y square divided by b square, which is equals to 1. X square divided by a square minus y square divided by b square is equals to 1. So first let us calculate the slope. Let us calculate the slope, differentiate with respect to x, so that we can get 2x divided by a square minus 2y divided by b square into y dash, which is equals to 0. Then 2 and 2 gets cancelled. So what we have, x divided by a square is equals to y divided by b square times y dash. Then dy by dx is nothing but b square over a square times x by y. Then the slope of the tangent. What is the slope of the tangent? B square x1 divided by a square y1. This is slope of the tangent. Then the slope of the normal. What is the slope of the normal? Minus a square y1 divided by b square x1. This is slope of the normal. Then equation of the normal. What is the equation of the normal? Equation of the normal is y minus y1 is equals to m. What is m? Minus a square y1 divided by b square x1 times x minus x1. So here it is b square x1 times y minus y1, which is equals to minus a square y1 times x minus x1. So try to simplify this. B square x1y minus b square x1 y1 minus a square xy1 plus a square x1 y1. If you simplify this, what you get? You get a square xy1 plus b square x1y, which is equals to a square plus b square times x1 and y1. A square plus b square times x1 and y1. If you send that x1 and y1 this side, a square xy1 divided by x1 y1 plus b square x1 y divided by x1 y1, which is equals to a square plus b square. So here y1 gets cancelled. We are getting a square x divided by x1 plus b square y divided by y1, which is equals to a square plus b square. What it is? This is the, what do we call this? Equation of normal. Equation of normal in point form. Understood? Equation of normal in point form. Important, sir. Okay, next what we have to do? We have to write the equation of the normal in parametric form. We have to write the equation of the normal in parametric form. In parametric form, we can take the point P as A secant theta comma B tan theta. We can take the point as A secant theta comma B tan theta. Okay, so in place of x1 and y1, if you replace this A times secant theta and B times tan theta, you can get the equation of the normal in parametric form. Already we have done the total, right? In this, it is as it is same, but what is the change here? A square x divided by A secant theta plus B square y divided by B tan theta, which is equals to A square plus B square. Here A and A gets cancelled. We can get AX divided by secant theta plus, here B and B gets cancelled, By divided by tan theta, which is equals to A square plus B square. So this is called equation of the normal in parametric form. What it is? Equation of the normal in parametric form. Got it? Next word, slope form. Okay, next word, slope form. Slope form, already y is equals to mx plus square root of a square b square, square root of a square m square minus b square. What it is? It is equation of a tangent, right? From that we can get equation of a normal also, or else we can calculate the slope dy by dx. We can calculate, then we can calculate the slope of the normal, slope of the tangent. From that we can get the slope of normal. After that we can calculate the equation of the normal, right? Next topic is pair of tangents. What is the next topic? Pair of tangents. So pair of tangents, next the equation of the common chord and the chord of contact, and the next one is when midpoint is given, what is the equation of the chord. These three are same for all the conics. These three are same for all the conics. Already we have discussed for parabola. Okay, and we also discussed for ellipse. Now we are discussing for hyperbola. What is this pair of tangents? What is the equation of pair of tangents? Equation of pair of tangents. What is this equation of pair of tangents? t square is equals to s times s1. So here already we know the equation of hyperbola. What it is? X square divided by a square minus y square divided by b square is equals to 1. Then what is t? T is nothing but x1 by a square minus y1 by b square minus 1, which is equals to s. What is s? X square by a square minus y square by b square times minus 1 times s11, x1 square by a1 square minus y1 square by b1 square minus 1. What it is? Equation of pair of tangents. Got it? This is the equation of pair of tangents. If we simplify this, we can get it. Right. Next, let us see chord of contact. So, equation of chord of contact: x square over a square minus y square over b square is equals to 1. So here, what is chord of contact? From this point, let us take the point is P. From this point, draw the tangents. This is the first tangent, and this is second tangent. First tangent is meeting the hyperbola at point Q. Second tangent is meeting the hyperbola at point R. Then join QR. This QR is called as chord of contact. This QR is called as chord of contact. Then what is the equation of chord of contact? What is the equation of chord of contact? The equation of chord of contact is t equal to 0. Equation of chord of contact is t equal to 0. T means what here? x1 divided by a square minus y1 divided by b square, which is equals to 1. This is called t, like s1. Okay. This is equation of chord of contact. Okay. Next one is, what is the chord of the contact when the midpoint is given? What is the chord of the contact when the midpoint is given? So here you see chord of contact when the midpoint is given. First, let us try to draw the figure for the given. Right. This is the hyperbola. What is the equation of the hyperbola? X square over a square minus y square over b square is equals to 1. Now here, chord of contact when the midpoint is given. So how do we draw the chord of contact? Yeah. Yeah. So these two are joined. So P and Q. So this is what the chord of contact. And here for this chord of contact, midpoint R is given. Midpoint R is given. Let the midpoint is x1 comma y1. Then what is the equation? What is the equation of chord of contact when midpoint x1 y1 is given? So t is equals to s1. T, what is the t here? X1 divided by a square minus y1 divided by b square is equal minus 1 is equals to s11. What is s11? X1 squared by a square minus y1 squared by b square minus 1. Minus 1 gets cancelled. X1 by a square minus y1 by b square is equals to x1 square by a square minus y1 square by b square. This is called, what do we call this? Equation of chord of contact when the midpoints is given. Right? Next. Okay. I think that these are the today's topics. Yeah, next one is diameter of the hyperbola. So diameter of the hyperbola, diameter of the parabola, diameter of the, you see, diameter of the hyperbola, diameter of the parabola, diameter of the ellipse. For all the conics, the definition is same. What is the definition? It is the locus of the midpoint of series of parallel curves. Diameter of a conic is the locus of the midpoint of, okay, series of parallel curves. Now let us see diagrammatically how it will be. Okay, so these are the parallel curves, right? For all these parallel curves midpoint, suppose this is these are the midpoints. So with these midpoints, this is called diameter of the, what do we call it? Diameter of the hyperbola. Okay. Let the midpoint is some p of h comma k. Midpoint is p of h comma k, and the slope is m. Slope is m. So equation of chord. This is the chord, right? Equation of a chord. So what is x1 square, x square by a square minus y square by b square is equals to 1. Equation of the hyperbola. X square by a square minus y square by b square is equals to 1. Equation of the hyperbola. Now calculate the slope here. What is the slope? Slope is 2x divided by a square minus 2y divided by b square times y dash is equals to 0. So 2x divided by a square is equals to 2y divided by b square times y dash. 2 and 2 gets cancelled. So y dash is equals to b square x divided by a square y. So dy by dx at h comma k, what it is? B square times h divided by a square times y. According to the problem, this is m. So m is equals to b square h by a square y. Then a square y is equals to b square h divided by m. From this y is equals to b square h divided by a square m. That is nothing, right? Here a square, this is a square k. Here it is a square k. A square k. It is k. So k is equals to this one. Here h comma k is the lowest point. Then y is equals to b square x divided by a square m. Okay, this is the condition. Equation of the diameter of the hyperbola. Okay. Any doubts still? Alright. That's about today's concept. Then here let us see the problems today. Before that, you can see the spark store here, long-term courses for 22-23 and crash courses for 22-23, and mock test, previous year solutions, full length test, and study materials. Okay, and they provide JEE mains, NEET, EAMCET, and IIT foundation. This is the offline atmosphere of the classroom. So here short-term crash courses and classroom coaching, offline classes, and the timings for long-term or short-term coaching is 10 a.m. to 4 p.m. and for the regular coaching the timings for 6 p.m. to 9 p.m. and the branches are and they have two branches, one in Narayanguda and the other in Hyderabad. Next, admissions are open. Admissions are open for NEET 2022 and mains 2022 and EAMCET 2022-23. This is about daily online live sessions. This is about the test details and statistics. Yeah, what is the methodology here? Here our methodology is basic concepts, shortcut methods, all model questions, exercise. Okay, then let us see the questions. Previous year questions. This question is JEE Mains 2020. So the question number one is, if a hyperbola passes through the point 10 comma 16 and it has a vertices at 6 comma 0 plus or minus 6 comma 0, then the equation of the normal to it at P. Equation of the normal to it at P. Hyperbola passes through the point 10 comma 16. So here, what is hyperbola? X square over a square minus y square over b square is equals to 1. This is the equation of the hyperbola. If a hyperbola passes through the point 10 comma 16, this hyperbola is passing through the point 10 comma 16. Then try to substitute that point. What do you get? 10 square divided by a square minus 16 square divided by b square is equals to 1. So 100 over a square minus 256 over b square, which is equals to 1. Let it be. And next what they have given, and it has vertices at plus or minus 0, and it has vertices at plus or minus 6 comma 0. That's a value 6. A value 6. So substitute a value here. If you substitute a value, 100 divided by a square, that is 6 square, minus 256 divided by b square, which is equals to 1. So from this, 100 divided by 36 minus 1, which is equals to 256 divided by b square. So 100 minus 36, 64. 64 divided by 36, which is equals to 256 divided by b square. So 64 ones, 64 fours. Then b square is equals to 4 times 36. Then b is equals to 2 times 6. Then b is equals to 12. So we got b value. And then what they're asking here, a value and b value both we got. A is equals to 6 and b is equals to 12. A is equals to 6 and b is equals to 12. So what is the equation of the hyperbola? X square over a square minus y square over b square is equals to 1. Equation of normal at p 10 comma 16. We have to calculate this. So here equation of a normal. What is the equation of a normal? X square by a plus y square by b. Okay, now is equals to a square plus b square. X square by a plus y square by b, which is equals to, one second, let us see the equation of yeah, see here the equation of the normal. What is the equation of the normal? A square x by x1 plus b square y by y1 is equals to a square plus b square. A square x by x1 plus b square y by y1 is equals to a square plus b square. Yeah, try to remember this formula. A square x divided by x1 plus b square y divided by y1 is equals to a square plus b square. Yeah, so not this one. X divided by x1 plus b square y divided by y1, which is equals to a square plus b square. And what is x1 comma y1? 10 comma 16. So try to substitute the 10 comma 16 here. If you substitute 10 comma 16 here, what do you get? A square. What is a square? 36 times x divided by x1. X1 is 10 plus b square. B square is 144 times y divided by y1. Y1 is 16, which is equals to 36 plus 144. Then this could go in 9 times and would be like 2 5s, 2 18s. So we can get here 18x divided by 5 plus 9y, which is equals to 180. 9 ones, 9 twos, and 9 20s. Then 2x divided by 5 plus y is equals to 20. Then finally we are getting 2x plus 3y is equals to 100. This is the equation of the normal, right? Next, let p of 3 comma 3 be a point on the hyperbola x square over a square minus y square over b square is equals to 1. If the normal to it at p intersect the x-axis at 9 comma 0 and e is its eccentricity, then the ordered pair a square comma e square is equals to. So here what they have given, p 3 comma 3 be a point on the hyperbola. First let us write the hyperbola equation here, that is a square over a square minus y square over b square is equals to 1. So let p 3 comma 3 be a point on the hyperbola. This 3 comma 3 is on the hyperbola. Then what do you get? 3 square over a square minus 3 square over b square is equals to 1. So from this 9 over a square minus 9 over b square is equals to 1. Right, let it be. This is equation number 1. If the normal to it at p intersects the x-axis at q, if the normal to it at point p, what is point p here? Point p is 3 comma 3. So let us calculate the equation of the normal. Equation of normal at p of 3 comma 3. So what it is? A square x by x1 square plus b square y by y1 square, a square x by x1 plus b square y by y1, which is equals to a square plus b square. So here x1 y1 is 3 comma 3. So let us substitute the 3 comma 3 in this. We can get a square x divided by 3 plus b square y divided by 3, which is equals to a square plus b square. So we are getting a square x plus b square y is equals to 3a square plus 3b square. 3a square plus 3b square. And here from equation number 1, a square minus b square. This is a square minus b square. A square minus b square and x equal to 9. Then you get a 9a square plus 0 is equals to 3a square plus 3b square. From this we can get 6a square is equals to 3b square. Then from this we can get b square is equals to 2a square. B square is equals to 2a square. And you see here, and E is its eccentricity. E is its eccentricity. So we can write B square is equals to a square of E square minus 1. This is eccentricity formula. So here B square is a 2a square. 2a square is equals to a square of E square minus 1. A square gets cancelled. 2 is equals to E square minus 1. Then E square is equals to 3. Okay, E square is equals to 3. Next, B square equal to 2a square. So use this b square is equals to 2a square, and let us calculate a value here. A square minus b square is equals to a square b square. So in place of b square we can substitute 2a square, then it is like a square minus 2a square, which is equals to a square times b square. A square times, what is b square here? B square is a 2a square whole divided by a square minus 2a square is minus a square, and 2a square times 2a square, 2a square times a square, this is a power 4 divided by 9. So finally what we are getting here, minus 9a square is equals to a to the power of 4, then a square times a square minus 9, a square times a square minus 9 is equals to 0. Then from this we can get a square is equals to 9. Here they are asking what is a square comma e square. So a square comma, therefore a square comma e square is equals to a square comma e square is equals to what we are getting, 9 comma 3. That's it. Clear? Okay, let us see the next question. Question number 3. Let a and b be positive hyperbola. So that lies on the hyperbola. X square over a square minus y square over b square is equals to 1. Right? On this hyperbola we have a point P. Suppose the tangent to the hyperbola at P passes through the point 1 comma 0. Suppose tangent to the hyperbola at P passes through the point 1 comma 0. So what is the equation here? Equation of tangent. Equation of tangent. Y is equals to mx plus under root of a square m square minus b square. So this tangent passes through the point 1 comma 0. Let us take the point is x1 y1 here, P point. Then this is y1 is equals to mx1 plus under root of a square b square minus b square. It is passing through the point 1 comma 0. So substitute here. 0 is equals to m times x1, that is 1, plus under root of a square m square minus, then b square is equals to a square m square minus em square. So b square is nothing but em square plus b square. This is the normal to the hyperbola at P. Cuts off equal intercepts on the coordinate axis. Cuts off equal, let us draw the figure. Let us take the point P is here. P of x1 comma y1. Right. At this point we have a normal. So it is touching x-axis at some A and y-axis at some point B. Here it is the center. Then they are saying that this OA and OB both are same. And at the point, the same point B, we have a tangent also. At the same point B, we have a tangent also. What is the tangent? Okay, let us draw the tangent here. This is the tangent. With the tangent at P. Delta denote the area of the triangle formed by the tangent at P and the normal. Okay, right. Let us take this point is some C. Then here we have APC triangle. If E denotes the eccentricity of the hyperbola, so E denotes the eccentricity of the hyperbola means B square is equals to, what do we get? B square is equals to A square times E square minus 1. B square is equals to A square times E square minus 1. So here let us take the point is x1 y1, we have taken a point. If we take this point as some A secant theta comma B tan theta, then what will happen if we take the point like this? Okay, this is the point A secant theta comma B tan theta. This is on the hyperbola also, right? So